Hello, welcome students. Today we will discuss Arduino microcontroller and its interfacing. So before starting with Arduino, let us discuss some of its important features. So in Arduino, microcontroller used is at Mega 328. So this is a very famous microcontroller which has a AVR architecture. So this microcontroller is used as a basic microcontroller in this Arduino Uno board, as you can see in this picture. Right. Second, this is the first feature. Second, it has a clock frequency up to 16 megahertz. So we can give the clock frequency to this microcontroller up to 16 megahertz. But you see here this particular board Arduino Uno has on-chip clock frequency, that is crystal clock of 16 megahertz inbuilt is available on this board. Alright. So third important feature is it has analog inputs. And digital inputs as well. So digital inputs. So this Arduino Uno has analog outputs and digital input outputs as well. So if you look at there are total 6 analog input output pins, as you can see on the board, A0 to A5. So total 6 analog input pins are there. Okay. So instead of output we can say they are inputs. Okay. Similarly, there are from 0 to 14 digital input pins. Out of these 14 digital pins, that is 2, 3, 4, 5, 6, 7, that is 6 pins are used as a PWM outputs. So therefore it has PWM output, and there are 6 in numbers. Okay. So this is very nice feature of this microcontroller, that we have inbuilt PWM outputs. 6 PWM outputs, digital outputs are provided with this particular microcontroller board. Here you can see this is a reset switch or reset button. This is a USB connector, and this is an important chip which is used to convert serial to USB converter. So this chip is a USB to serial converter. Alright, and this special power jack is used separately to power this microcontroller. So power can be applied from 0 to 5 volt. Okay, so this is, but this microcontroller board has 2 different power supplies. One is 5 volt and another is 3.3 volts. So this microcontroller can work on 3.3 volt as well. Okay. And like any other microcontrollers, we can interface all the types of devices, sensors to this board, and that's why nowadays this microcontroller is becoming very famous. Okay. Now quickly, without wasting time, we'll go to the Proteus simulation, and therein we'll saw the interfacing of a DC motor to this particular Arduino board and how to write a program. So for that we have to open this particular sketch, okay, Arduino input sketch, wherein we can write the program. Okay, you see this particular IDE, Arduino IDE, has 2 different functions. One is void setup and another is void loop. So here we have to write the code. So this software is freely available on the net. We can download it. okay, and we can install it. We can make use of this IDE to write the program for Arduino boards. Okay, this is my programming environment, and in Proteus you can see this is my interfacing diagram. This is my Arduino board, Arduino Uno board. I can pick up it from the libraries available in the Proteus itself, but by default this Proteus do not come with this Arduino library. We need to install these Arduino libraries from the open source platforms. So we need to download those IDX and lib files, and we need to copy those files. So I will provide the link in the description box. You can see the links. You can download those files and copy it into your Proteus software library folder, and then you can make use of this Arduino microcontrollers. Okay, so here I have already installed these libraries into my Proteus software. So this is a Uno package, so I am using, and as you can see, I'll just zoom it a little bit. I have connected two different motors to this Arduino Uno. You see carefully, pin number 9 and pin number 10, both these two pins are connected to two different motors. Here I will show how to control the rotations or the movement of these motors. Okay, in simulation we do not require to power this Arduino board, so this is very important feature of this simulation. So our advantage, in other words, we can say that we do not require any extra power supply or anything here. We need to simply connect these DC motors, and we need to download the program. Okay, so for writing the program, we'll move to the Arduino IDE. We'll write a program first of all. So here in the IDE, we need to begin the setup. So for that, we'll start writing the code. So code is something like this: serial dot begin. So here we are providing a baud rate of 9600. So 9600 is the baud rate. With the help of this baud rate, we can communicate with the computer and the board. So this is my baud rate. Then I am defining, you can see here, I have connected these DC motors to pin number 9 and pin number 10. So I will define these two pins as output pins. So for that, I will write a command, pin mode. This is a command used to define the direction of Arduino board. Pin mode 9, I am defining it as an output pin. So this is the syntax of the command. So I will write here in a comment that pin number 9 is output. Right. So next I will copy this and paste it here, and I am making pin number 10 as well as a output pin. Okay, so I have defined both these pins in output mode. Now what I will do is I will write some value to pin number 9 or pin number 10, so that it will take that value as a voltage percentage, and it will provide that as a signal to the DC motor, and will start rotating the motor. So for that I will make use of a command, analog write. This command will write to the output pin, so pin number 9, and I will provide the value, let's say 150. Okay, so after writing this value, for this particular span wherein pin number 9 motor is rotating, during that time I want to make a motor which is connected to pin number 10 as in off position. So for that I will provide a value, analog write to pin number 10 is a 0 value. Okay, so pin number 9 is so DC motor to pin 9 starts, and here I will write these are the comment statements I am writing. So comments are put by double backslash. So DC motor to pin 10 is stop. Okay, stop. So after doing this, now I need some delay. So for that I will write a delay of, let's say, 2000 milliseconds. So this delay is by default is in milliseconds. So after a delay of 2000 milliseconds or 2 seconds, what I want to do is I want to make pin number 9 DC motor to stop and pin number 10 DC motor to start. So for that I will copy these statements and paste it here, and at pin number 9, now instead of 150 I will make it 0, and at pin number 10 I will make it 200, so that now my pin number 10 DC motor will start rotating. So here instead of stop, now it will start, and previously the motor which are connected to pin number 9 will stop. Now after this, again I will put a delay of, let's say, 2000 millisecond. So I made a mistake, delay. Now again I need to write 0 values so that both the motors will get stopped. So pin number 9 I will send 0, and same command I will copy and paste it here, and this will make motor of pin number 10 will go off. So this is a simple program which I have written. Now simply verify this program. You can see it will take some time to compile and verify your program. So let's wait for some time. Yes, the program is executing. It will take some time to execute. Yes, execution is over, and once it is over, you can see your hex file is created in this folder, C:users. This particular path is given to you, so you have to select this hex file and download it onto your microcontroller. So we'll again go back to our Proteus simulation. Then we will double click on the microcontroller. We will select the folder and the respective path. So this is the path. I will select the hex file and simply click on OK. And now your simulation is ready to run. If I run it, you can see your first motor will start rotating. It will rotate for some time. I have given some delay, then it will stop, and then this motor, second motor, will start rotating, then both motors will stop. Okay, so this is the simple simulation. So the next part of this video, I will demonstrate a physical connection of Arduino board with the DC motor, and I will show how we can make use of this Arduino board to rotate the motors, and actually we use it in designing various robots. Okay, thank you. Students, you see this is Arduino board. This is a LM293D motor driver. This is a simple DC motor which I am going to connect to this board, and this is a simple USB cable which I need to make a connection of this Arduino board to the PC. So let us start making connection. So you can see there is a plus 5 volt and a ground. So these two pins I need to connect to the positive and ground supply of this 293 board. So I will connect it here. So positive pin is connected to positive. So I will connect it here. And this ground pin is connected to the negative terminal. So after giving supply, now you can see pin number 9 and pin number 10 are having PWM outputs. So I am connecting these two pins to the 293 driver. So that's why I am connecting this to this socket. So first pin is connected here, and second pin is connected here. You should be careful while making these connections, because wrong connections will not make motor to rotate. So after these connections are over, now I need to connect my DC motor. So for that, this is a DC motor. I am connecting it to here. So let me connect these two pins. So first pin is connected here, and second pin is connected here. Now my connections are over. Now what I need to do is I need to connect this USB cable to my microcontroller board. So that's why I am connecting this, and I am connecting it to the PC. So for that, yes. Now go to the simulation. IDE, Arduino IDE. This is the program which I have written already. Now we have already compiled this program. Only thing is that you need to check some settings. So you go to the tools, and in tools you select this board, that is Arduino Uno. Okay, once you select that, you confirm that your port is COM4. Okay, so once all these settings are okay, then you can download this program by clicking, see here, upload. So when I click on this button, your program will get download onto the Arduino Uno board. So that's why when I click on this upload button, my program will start downloading. You can see here my program is downloading. If some errors are generated, then it will show errors, but now fine. You can see my program is running. You can hear the sound. I will reset my microcontroller so that you can hear it. I will again reload. I will again execute the program. You can see carefully. In this way, we can interface the DC motor with Arduino board.